Hi, I'm Sean. I make stuff, I break stuff, sometimes on purpose, and sometimes a cool guitar comes out. Can this be used to finish aluminum parts? To make the guitar like that, we use a lot of this stuff. 1-inch square, 16th inch wall, 6061 aluminum. Nothing special about that, especially when you buy it bulk and it comes with a surface about like that. Hope you can pick that up in the light. And various handling marks and scuffs and so on. And then when we go to work with it, depending on what tools we're using, we'll get burrs from flat cuts, from round cuts, and drilled holes. We want all that to go away. We'd like all the parts to look more like this. This was a test piece to test polishing methods and then the engraving. That looks a lot nicer. This other piece also got a little work. Only got part way. Except the thing is, this got about as much work as this did. This piece came from the big box store with a name brand label on it. They charge more, a lot more, but they do carry nice stock. Problem is, when you're using feet at a time like that, you want to use the cheaper stuff. So let's look at how we're going to do this and how we did it, starting with a new big box of the cheap stuff. So what did we get? Got some 1x2 inch. Not looking too bad. Oh wait, no. The surface has its share of defects. Same with our 1xs. Some really good nonsense going on down here. What are we going to do about all that? I went through quite a variety of different options for trying to polish these parts. I'm not going to go through these all in detail. I'm just going to show you one example. Just want you to know that we went through brass. This scary thing showed up that I didn't even want to try. Stainless steel in different shapes and different densities. Buffing pads. Multiple grits of compound to use with the buffing pads, and none of that really works the way you'd like. We'll show you why. Alright, here we are set up by the drill. This piece I'm going to use, it's pretty rough. It was actually used as a first test for the engraver. Anyway, a lot of handling marks, a lot of lines from the extrusion direction. Pretty rough stuff. So let's get this thing moving and see where we want it to be. surface a bit. Crud stuck in here. Or maybe not. So that's done its own thing. It left a different kind of surface, not great yet, but it got the factory marks off. Let's change it to the buffer and go to the next step. Slow it down a bit. Starting to get, a little more work. I'd be happy with that. And just look at the difference between the factory finish and what we got too. But also, that was, the camera says we're going on 5 minutes for this recording. There's a few minutes for the other one. And that was for less than 3 inches of one side of one piece. We don't want to do that. People don't want to pay $8,000 for these guitars. Trust me, I've tried. We need to get the man hours down to something reasonable. So, let's think about what we're going to do. So I've got all the current 1x1 inch stock that I've got on hand. We're going to pick a piece to use and make it our sacrificial lamb for this finishing test. I'm thinking this guy here has the most handling marks and pretty good set of extrusion lines. So that's going to get cut up into samples. Oh, well, shoot. That's all right. So the tools I have to use right now, this chop saw and table saw, are going to come into play. They both have blades on them, which are already responsible for building Most of this shop, you see, all the ceiling boards, all the studs, everything we're standing on was all cut with these two. I'm not going to change the blades because I want kind of a worst case scenario on the quality of these cuts. We want to see how the burrs come off when we throw them in the cement mixer. So we've got a stop set. Let's keep on making some parts. Now that our blanks are cut, we need to make them into distinctive parts which have some features and make them look more like what actually goes on the instrument. So this is what the part's going to wind up looking like. We've already done, we've cut to length, we've cut our angle. We want to make holes such as what happens if this part got screwed to another one. It would have through holes here for screws and a through hole here for the screwdriver. And I also want to simulate the kind of engraving that gets done and make each one distinct. And I want that to be done by the same CNC machine that's going to do the real parts. So we have to cheat because the CNC software is a little dumb. Here we are. We've got 4 parts laid together. But as far as our CNC software knows, it's just one solid block. We're going to tell it to cut through one side a little deeper than the actual thickness of the part. And I've added the text so that each one gets a distinctive mark. A, B, 1, and 2. I'm going to try to finish these in pairs. So what happens when that actually gets put into the CNC? What we have here really is not a great setup for milling light metal. These kind of mini CNC machines are more often used for carving out wood. They do a good job on metal eventually, but the setup's a bit tricky. Here I've got an itty bitty 16th inch 4-flute end mill, and the teeth come by way too fast. It's really it's making more dust than it is chips. But we're getting there eventually. I've got a little air cooler set up. I usually spray a little oil on the metal before we start cutting also. I had this dialed in better on a previous part. I just don't remember what those settings were. We'll get back to it. In this case, we actually wanted kind of a rough end product to see how our finishing method is going to work. What she's going to do next is go back there and we'll see drilling out some of these holes. It's the dumbest way possible to drill out the holes, taking a small cutter that's going to cut the flat of every hole and every layer many times until it's just cutting air. It takes forever, but I don't care because I got to go do something else while this thing ran for an hour. Okay, I brought the focus up tighter so we can see these holes here. They do go through. Our letters look a little gnarly. We'll see how that polishes out when the burrs come off. There's one of our holes. Yeah, we can see that's going through. Surface is still, ready for polish, let's say. Anyway, that's our first shot at these. So our parts aren't quite ready for trying to polish them yet. These holes we made on the top, I'm calling it the top, are supposed to be 3/16, which is a clearance hole for the screw that goes through there. But if there's a screw that goes through this way, we need screwdriver access this way. So I got another drill, a little bit bigger than a screwdriver. But we already have the 3/16 holes drilled to one side, thanks to the CNC mill. That gives me a pattern to drill through the other side and then enlarge that hole to make the tool access. So let's just bang those out. Now that little bit of drilling has left us, once they come into focus, a bit of a burr on this side where we drilled through, but now we're going to drill through the other direction and put a bigger burr, but on the inside. So now our part is pretty clean on this side, but on the inside where it broke through, it's kind of gnarly. So hopefully when we put this in the tumbler, our media is going to get inside there and clean those up. We can talk a bit about how this deburring would go if I had to do it by hand. I do have a collection of tools just for the purpose. I think most people would recognize this edge deburring tool. It's good for getting into big round holes and taking off an edge that sticks up on the outside of a round hole, one that's big enough for this guy to get into and move around in. Okay, great. Another way to do that for medium-sized holes, this little lovely hardened deburring tool. Hopefully it's hardened. Does kind of the same thing. Which one is this so I know which one I did? A2, okay. This guy works in the smaller holes as well. Oh, it takes a little more. Yeah, it took a little more than that. Yeah, it takes a bit of work, but It's making progress. Now, what if I wanted to get on the inside of that and clean that up? Can we see down there what's sticking up? Kind of ugly. This outfit, Noga, makes a variety of deburring tools for different situations. This one fits inside. We can manipulate the tool. And with some control and effort, start to dig burrs out of there. Difficult to get fine control, and again, time consuming. Now for even smaller holes, or deeper ones, this wicked little fellow with the collapsible blade can stick up inside. Oh, these are actually too small. Let's take one of these guys. That sticks up inside. There we are. Problem here is I'm too close to the wall. I don't have access. So each of these tools has their shortcomings and strong suits. They all take a lot of time to use. We're going to see if we can't just chuck it in a bath of rocks and make something good happen.